All right, everybody, we are going to complete our last section of the first part of Chapter 3 today. And we're still working on proving. Now we're actually going to get into proofs. And we're going to look at segment relationships, which is something that you looked at back in Chapter 1. So by the end of today, hopefully, we're going to start off by saying, I am learning how to write geometric proofs that show how segments are related using clear steps and logical reasoning. A proof is showing your work. A proof is justifying the work that you're showing. That's all this is. So, by the end of the day, I can identify the given information and what needs to be proven in a geometric problem. I can use appropriate definitions, postulates, and theorems to support proofs. And I can construct logical arguments that lead from the given information to the conclusion. So again, we know how to solve 3x plus 12 equals 15. A proof is showing the justification using some of these properties of equality that we started in 3-4. We wrote all these down, said how they went together. Properties of equality, the addition, subtraction, multiplication, division, distributive, substitution, reflexive, symmetric, and transitive properties must have an equal sign. So when you're doing a proof and you have an equal sign, you're probably going to use one of these. How many are there? 9 right here? One of these 9 properties. We're going to start off today looking at a couple properties of congruence. Now, what's the difference between congruence and equal? Well, there's not a whole lot of difference, but normally when we're talking about congruence, it's showing a side is equal to something else, or an angle is the same as something. Not too often do we really show congruence in that, but they're pretty similar. So, yeah. If we need to remember an equal sign, well, if you see that, that's equals. Congruence, well, congruence is an equal sign with a little squiggly on top of it. So that's when we're saying that something is congruent. Okay? So, let's go through these couple congruence properties real quick. So the first one is the reflexive property of congruence. So, remember in 3-4, reflexive meant the same thing. So for any segment, we're looking back at chapter 1, when we're drawing a segment, it's just a line. So segment AB is congruent. Well, for reflexive, we're just writing the same thing. So segment AB is congruent to segment AB. All right. Symmetric is the one that flips. So this time, I'm going to say 2 different line segments. If segment AB is congruent to segment CD, by the symmetric property, we are able to flip this and simply say that segment CD is congruent to segment AB. Again, I know that doesn't seem like it's a big deal, but you're going to run into proofs where you're going to need that. All right. Last one of these is the transitive property of congruence. So again, we're taking a piece out of one, replacing it into another. So I'm going to use this same AB congruent to CD. So segment AB congruent to segment CD. Then I'm also going to say that segment CD is congruent to segment EF. So what we talked about last time was we're going to take the hypothesis, the first part of the first statement, the conclusion of the second statement, and bring those together for the transitive. So we're taking the thing that is similar out. So we have segment AB is congruent to segment EF. Reflexive means the exact same. Symmetric is where we flip it. Transitive, we take out the thing that's the same. All right, again, that's congruent. So if you have the equal sign with the little squiggly on top, you know you're going to use either the reflexive property, symmetric property, or transitive property of congruence. If you have an equal sign, you can use any of these 9 up here. All right. 2 more quick definitions. And our first postulate that really you've already gone over this here, so we're just going to go through that quickly. All right, so definition of congruence. Okay? Segments are congruent if and only if they have the same measure. So what we're able to say here is this is where we're going to combine congruence and equal. So if they are congruent, so I'm going to come back up to our statement up here. We said that AB was congruent to segment CD. These are just examples, guys. I'm pulling these out of nowhere. All right, you're going to start getting into math where you're kind of just coming up with examples. All right, so segment AB. So if segment AB is congruent to segment CD, then AB is equal to CD. Doesn't seem like it has a lot, but it does. We're going to say the converse of this. Again, we talked about that before, where we're switching our hypothesis and conclusion. So AB is equal to, if AB is equal to CD, then segment AB is congruent to segment CD. All this is going to come into play once you actually start writing proofs. So let's take a look at the definition of a midpoint. We've talked about midpoint in class. We know the midpoint is in the middle. So if it says that M is the midpoint of AB, what do we know about AM and NB or MB? If M is the midpoint, that means it cuts our entire line in half. So what do we know about AM and MB? Well, that means they are congruent. Congruent. So we're able to write, if M is the midpoint of segment AB, then AM is equal to MB. We don't want congruent, we want equal. Okay? So we want to end here. We could have put that segment AM was congruent to segment MB, and then put AM is equal to, but this was our end goal. We wanted to show that these two parts were equal. So we just skipped using the definition of congruence. If the segments are congruent, then the lines are the same. That's all we got there. All right, and for this last part on this page, the segment addition postulate. If A, B, and C are collinear points and B is between A and C, well, segment addition. So we're going to take this first part, that first segment, we're going to add it to the second part. Well, if we're adding, we're trying to equal it to something. So AB plus BC is going to equal what? Well, it's going to equal the whole line. So we're going to be able to say that so I'm just going to go straight to the end. We're skipping the congruent part because we want equal here. All right, everything we're talking about is equal. So we're using this, again, the definition of congruence to skip this part. So we're going to say AB, that first part, plus the second part, BC is equal to the whole thing. So AC. That's what you guys did the first chapter. Some of you got it, some of you didn't. I told you we were going to come back to it. But a lot of your proofs are going to deal with this or have this be part of it. A lot of your proofs are going to have this, the midpoint, be part of it. So we got to understand these two things. If you do not understand these two things, you better ask somebody, ask someone around you, ask myself, ask Mr. Short, ask somebody if you still don't understand these two things. All right, we're going on to the next page. There's a lot of notes in this one. It's going to be a little bit. All right. So we're going to take a look at an actual proof. Okay? We got two of them on this page. We're going to justify each statement using a property of equality, property of congruence, one of our definitions, or postulate. All right? So, we're just going to start going through this. These are not in any order. So this isn't a proof yet. This is doing what we did back in 3.4, where we're just naming all the different properties, the definitions, and postulates. So this should look like something we just did on that front page. If PQ is equal to PQ, then segment PQ is congruent to segment PQ. Well, that was the definition of, I'm going to shorthand it, I don't want to write congruent. Well, there's room here. Congruence. Again, that's the squiggly sign with an equal. Okay? So, if K is between J and L, then JK plus KL equals JL. Again, if you go back to that first page, down there at the bottom, you had this exact line. They just used different points. Instead of ABC, they used JKL. So this was the segment addition postulate. All right. And all these are just looking at that front page and matching them. You're going to have to match things up as we're going through proofs. All right? So number 3, EF is congruent to EF. You have the same thing congruent to itself. This isn't the reflexive property of equality. It is the reflexive property of congruence. But we don't have to write all that. For right now, we can just write reflexive. Okay? What I want you to do is I want you to try to fill this out using that front page. Okay? Try that out. Pause the video for a second. Come back when you're done. See if yours matches mine. All right, welcome back. So, let's go through these again real quick. We flip them. Symmetric. If Y is the midpoint, well, that tells you right there it's midpoint. For number 7, we got rid of the thing that was the same. Transitive. 8, subtraction. We subtracted to get from AB plus CD equals EF plus CD. Well, we subtracted CD, so we got rid of it. Substitution. You started with PQ plus RS equals TV. You ended with PQ plus WX equals TV. So all we did was we changed those out, and we did that because we knew that they were the same thing. Substitution. Another where they talk about midpoint in it. Again, that's probably a dead giveaway that it's definition of a midpoint. Congruent to equal, definition of congruence. CD plus DE equals CE. They took DE away to get CD by itself. We wanted XY by itself, so we divided by 2, division. We got rid of the thing that was equal, or we got rid of the thing that was the same. Transitive. All those things, all right? And those are all of the just matching things, going through it, making sure that we understand and we can read so we can start to justify what we're doing. That's what we're going to get into right now with this first proof. The first thing we are told is that E, point E, is the midpoint of DF. We are told that. So automatically, what do we know if E is the midpoint of DF? Well, automatically we know that these two lines are congruent because it's the midpoint. It cuts it in half. So before we even start, we can say that. We are trying to prove that 2 times DE, so 2 times this portion, equals the whole thing. And that makes sense, right? Because this side and this side are equal. There's 2 of them. It equals the whole thing. So why do I need to do this? This is the justification portion of math. All right? So this is what you're going to see a lot of times on proofs, whether it's your test, whether it's the EOC at the end of the year. They're going to give you the statements. They might give you some statements, they might give you some reasons, but they're going to give you portions of this. So you either have to provide the reason or provide the statement. They're starting you off with all the statements. E is the midpoint of DF. All right? Well, how do we know that? What's the reason for that? Well, they tell it to me right there. Your first reason in a proof is almost always, if it's not 100%, then it's given. The first reason should always be given. Okay? Now, second step. How do we know that DE is equal to EF? Well, how did we know that? We already said that DE was equal to EF. That was, if we come back up here, that was our definition of a midpoint. If we have a midpoint, we know that these two are equal. So we can say definition of midpoint. All right. So now we're looking at how do we go from DE equals EF to DE plus DE equals DE plus EF? What happened? What did we do here? Well, we added DE to both sides. We're allowed to do that. We're adding the same thing to each side. You get $2, I get $2. Everyone's happy. So we added, it was the addition property. What you do to one side, you have to do to the other. All right? So now, going from step 3 to step 4, now we have 2DE equals DE plus EF. What did we do from step 3 to step 4? Well, we took these 2 DEs and we combined them just like you would a variable. So like this is like saying x plus x equals what? Well, 2x. Now, is that the addition is that the addition property? Did we do the same thing to each side? No, we just worked on one side. So that's simplifying. That's combining like terms. Okay? And then finally, we got from 4 to 5. Okay? How can we say, given what we have right here, we have DE plus EF, we have DE plus EF right here, DF, 2DE. Oh, again, sometimes it's not going to be going from one to the next. I know it looks like it should be. But how do we know that DE plus EF is equal to DF, the whole thing? Well, if we go back to page 1, that's right here. We said that the first part plus the second part equals the whole thing. So that is the exact same as what we have at this part of the proof. The first part plus the second part equals the whole thing. So that is our segment addition postulate. This is the hard part about proofs, is you have to know your postulate. You have to know these theorems. You have to remember these things, because going from step 4 to step 5 would be impossible without knowing the segment addition postulate, without being able to see part 1 plus part 2 equals the whole thing. That would be impossible. Okay? But now we're able to take the information from these last two. Because again, I mentioned we have DE plus EF, we have DE plus EF, but they're equal to different things. So let's take the first part of the first statement, the second part of the second statement, and put them together. What property is that? When you get rid of the thing that's the same. So if we're getting rid of DEEF, DEEF, what is that property called? Well, that's the transitive property. And now we are where we wanted to end up at. 2DE is equal to EF. We have proven that all the things that are right here on this page. We didn't have to come up with anything else. We didn't have to know anything else. It was all right here on this page. That's what your proofs are going to look like for this chapter, or for this section. Okay? So, let's flip the page. Let's look at the next one, which again, all of these are going to be things that are already here. We already know it. It's on that first page. Okay? So, we're back to the midpoint. K is the midpoint of JL. M is the midpoint of LN. JK is equal to MN. So, we know right now JK, so this one over here, is equal to MN. All right? We also know that K is the midpoint of JL, M is the midpoint of MN. So what does that tell us? If this and this are congruent, but K is the midpoint, well, that tells us that that's congruent as well. Now, that should be clear to us, but that's what we're trying to prove. We're trying to prove that KL is congruent to LM. So yes, in 3 seconds we can say, all right, K is the midpoint, so JK is the same as KL. M is the midpoint, so LM is the same as MN. I was told that JK and MN were the same, which means these two need to be the same. But why? That is what we're trying to figure out with this. We're trying to figure out the why of it. Do you care about the why? Well, some of you do, some of you don't. But that is what this chapter is getting to for the rest of this. I'm introducing it to you, this first part. Second part has a lot of this stuff. All right, so let's go through this. Statement 1, K is the midpoint of JL, M is the midpoint of LN. Well, that's part of our given. So we're going to throw that in. Something I didn't mention on the last one, but I'm going to mention here. If there's a lot of things given, it may be spread out. So let's see if somewhere else in our statements there's part of our given. All right, so we did this first part. K is the midpoint, M is the midpoint. Is there anywhere in our statements that shows that JK is equal to MN? Well, that's step 3. So let's throw a given right there. If it's given, you get to write given. You don't have to worry about anything else. All right? So now we're going to look at step 2. JK is equal to KL, LM is equal to MN. JK, KL, LM, MN. Well, we already said they were congruent. We already said they were equal. How do we know? How do you know that that's true? Well, that's the definition of a midpoint. All right? So now we get to skip down a little bit. We already did step 3. JK was equal to MN. Now we're looking at MN is equal to KL. LM is equal to MN. All right, well, let's take a look and see. My first thought is, well, that looks a lot like statement 2, right? The only difference is that we have JK in the first one, we have MN in the second one. So what's it called when we change out one thing for another because we know they're equal? We're not getting rid of the same thing, we're changing it out. We are substituting. So it's the substitution property. All right. So now we have LM is equal to KL. So let's see what we can figure out. We have KL right above us, so that might be helpful, but that's an MN. Okay. Let's take a look where else. Is there anything that's the same between these two statements? Well, the MN is the same. So if we didn't have that, KL, LM. Let's get rid of the thing that's the same between those two equal statements, those two equality statements. If we get rid of something that is the same between two statements, that's the transitive property. All right? LM is equal to KL. Now we have KL is equal to LM. What did we do? We flipped it. What property is it called when we flip something? Well, that's the symmetric property. Then finally, we have the same statement, but instead of KL is equal to LM, it says segment KL is congruent to segment LM. So that is the definition of congruence. I'm asking you to show your work, to justify your answers in this section. This is logic, something that we don't like a whole lot of. I get that, I know it, but that's what this section is. Right, let's move to this proof in the middle. Okay. So start with the given. Segment XY is congruent to segment UV, and segment YZ is congruent to TU. So where is that in our proof? Well, that's step 1. So given. We are trying to prove that segment XZ is congruent to TV. So if we look up here, XY is congruent to UV. So we can put our little line right there. All right. YZ is congruent to TU. So we can put the two little lines there that says that those are congruent. It means that these are different. XY is not the same as YZ. TU is not the same as UV, but they are congruent to something else in the problem. Our goal is to show that XZ, the whole thing, is congruent to TV, the whole thing. Well, let's just think about this and see what's going to help us. We've got two line segments. We have the pieces of each line segment. That tells me automatically if I've got the pieces of two segments. There's no mention of midpoint anywhere, just two segments, and we're trying to make the pieces of the given equal the whole thing. So that tells me somewhere I'm going to have segment addition. Might not be the end, but I know somewhere in this problem we're going to have segment addition. All right, so let's go through this, see what we can find. Step 1 to step 2. XY is equal to UV, YZ is equal to TU. Well, we just got rid of the segments. We made it equal instead of congruent. So that was the definition of congruence. Definition of congruence. All right. Now, next one. XY plus YZ is equal to XZ. Well, the first part plus the second part equals the whole thing. The first part plus the second part equals the whole thing. Well, there's my segment addition right there. Segment addition postulate. Okay, so let's keep going. UV plus YZ is equal to XZ. YZ plus UV is equal to TV. And it looks a lot like this, but we kind of moved some things around. YZ is the same, so that stayed, but XY and UV changed. UV stayed the same, but TU and YZ changed. Well, what do we know about XY and UV? They're equal. What do we know about TU and YZ? They're equal. We changed them out. We replaced. We substituted. This would not be fun if you had to write the whole thing. I get that. I know. That's why we're not making you write the whole thing. You just have to match up the theorems, the postulates, the statements that go together. Okay? Now we have XZ is equal to TV. Well, we went from some really long statements to little. We got rid of stuff. Well, let me look at what's not here anymore. UV plus YZ. Let me see what's not here anymore. UV plus YZ. We got rid of the thing that's the same. What is the property called when you get rid of the thing that's the same? Well, that's a transitive property. Transitive. I can spell. You guys know I can spell. Yep. Transitive. Finally, we added the segments, we added the congruence. That's our definition of congruence. Wonderful job. We are getting there. I know this is a lot. I know this is a long video. We're almost done. We just have another, page and a half. Complete the proof by giving the missing statements and reasons. So E is the midpoint of AC, and DE is equal to EC. So we have two given statements there. So let's fill that in where we can. E is the midpoint of AC. That's given. DE is equal to EC. Normally we would put that on the second one, but that's not supposed to be there. There's a given here, though. So let's put the second part of the given where they told us to. That's supposed to be an E. Okay. So we're just filling that in. We haven't started anything yet. We're not there. E is the midpoint of AC. So let's go to our picture over here. E is the midpoint of AC. So what do we know about AE and EC? They're the same. We also know that DE is equal to EC. So EC is the same as AE, which should also tell us that if DE is the same as EC, then DE should be the same as AE. Well, look, that's what we're trying to prove. So our job is to justify the answer of how we're able to say these two are the same, AE and EC. These two are the same. We were told that. That's our given. These two are the same because of the midpoint. These two are the same because it was given to us. So we're trying to prove that these two, DE and AE, are equal, are congruent. All right? So E is the midpoint of AC, given. Definition of the midpoint. If we go back up to that first one, for definition of a midpoint, that's just saying which two lines are equal to each other. So definition of a midpoint, we're just splitting this up. AE is equal to EC. Okay? So, we have our given statement. DE is equal to EC. We knew that was given. AE was equal to DE. right? These are the same. They're not in that next statement, but the other two pieces are. What do we call it when we get rid of something that's the same from two statements? That's the transitive property. All right. Next one tells us definition of congruence. Everywhere else that we've seen definition of congruence, we either went from equals to congruent, or on the last page we went congruence to equal. Well, we have equals right here, so let's make it congruent. Segment AE is congruent to segment DE. Definition of congruence. And then finally, what happened between 5 and 6? It flipped. AE is now second, DE is now first. What's it called when you flip your statement? That's symmetric. I'm asking you to justify. I'm asking you to think through the process. Given this information, we can say immediately that DE and AE were congruent. But you have to be able to justify. That's what we're going through right now. Justification of our answers. All right? 3 more proofs. Okay? We'll get through this. I promise. All right, so first things first, given RS is equal to half of RT. So this first part is half of the whole thing. The first part is half of the whole thing. I'm talking 2 pieces of the whole thing. That tells me we're going to have segment addition. It's half. So that means S is in the middle. That tells me somewhere we're going to have midpoint. And unfortunately for you guys, they already gave us those 2. So we have to come up with everything else. Step 1, RS is equal to 1/2 RT. That was given to us. Like I said, that first reason should always be given. All right. Second step, 2RS is equal to RT. What happened between step 1 and step 2? We got rid of that 1/2 by multiplying by 2. So multiplication property. If you want to be extremely correct, it's the multiplication property of, it's an equal sign or congruence? Equality. All right. They told us segment addition postulate right here. So, what are our pieces? They're adding together to the whole thing. That's what segment addition means. 2 pieces added together equal the whole thing. So we're able to say that RS plus ST equals RT. Okay? How's that? So, this next step is where it could get a little tricky. All right? Some people will say this next step is substitution. Some people will say this next step is transitive. You're not going to be wrong either way. We're going to take a look at statement 2 and 3. RT is the same. We have 2RS and we have RS plus ST. We're getting rid of the thing that's the same. So that can be transitive. We could also say, all right, 2RS and RT are the same, so I'm going to substitute that in for RT. So right here, I'm going to put, the thing that we've used more of today is the transitive because we got rid of the thing that was the same. So I'm going to say transitive here. If you saw that and you saw a substitution, that is just fine. Okay? Normally there's more than one way to solve these problems. They try not to do that because a lot of these are multiple choice, but it happens sometimes. So now we're looking 4 to 5. How do we go from here to here? Well, there's only ST on this side, so maybe we're going to subtract. Maybe we're going to subtract. And that's what they did. They used the subtraction property of equality. I'm not going to write all that out. And then finally, definition of a midpoint. Well, we already said that RS was equal to ST. That's already there. So we're not going to write that same thing again. But we've proven that RS is equal to ST. We're trying to prove that S is the midpoint of RT. The given should be the first statement. The prove should be the last. Given should be first. You might also be somewhere in the middle, and it's and the prove is the last. All right. This one in the middle. You know what? I want you to try this one. I'll fill it in for you, but I want you to try this one. And then we'll go through the last one because that's a whole proof on its own. All right? Pause the video. Try this last one on your own. Was the exact same. The first was given, then it's a definition of a midpoint. The second was given, definition of a midpoint. They told us transitive property. So that tells us that we got rid of the thing that was the same. So, what was the same between the statements that they gave us? MN and MN. So we were left with LM is equal to NO. Definition of congruence. We change equal signs to congruence. All right? Last one. I know this has been a long video. I get it. It's probably taking you 2 days to get through. That's okay. All right? So, let's start this entire proof. We got to figure out the statements. We got to figure out the reasons. Let's help ourselves out for a second. The given is going to be the first. AB is congruent to CD. Segment AB is congruent to segment CD. We know that is our given. Our prove, that thing down here, it's our last one. Segment AC is congruent to segment BD. Okay. We don't know the given for that one yet. We got to figure that out. But we know that AB is congruent to CD. We also know, well, we don't know anything else. That's all we know right now. We're trying to prove that AC is congruent to BD. So if we know that these two pieces are the same, in order for the whole things to be the same, well, BC's got to be equal to BC because that's the part that matches. Let's see if we can't figure something out there. We don't really like to deal with congruence if we don't have to. So a lot of times when you're given congruence to start out with, just like when on the page before us, when we were given statements that were congruent and we took them to equals, you're generally going to want to do that. So AB is equal to CD, definition of congruence. All right, so we know that AC, again, this is where we kind of got to figure things out on our own a little bit. We know that AC is made up of AB and BC. The two parts equal the whole thing. So what we're going to say is that the thing that we're trying to prove, AC, that's equal to AB plus BC. Right? How do we know that? Well, that's our segment addition postulate. Segment addition postulate. That's not just something we're making up. We know that that's a fact. We just have to state it. How about BD? We said AC. Well, how about BD? What makes up BD? Well, BD is made up of BC plus CD. That's the segment addition postulate again. All right. Do you notice that we have two of the same statements? Normally when that happens, we're going to take part of this and put it in here based on what we already know from statement 2. AB is equal to CD. So let's replace AB in this first statement with BC. So we're going to say AC is equal to CD plus BC. How did we do that? We replaced AB in statement 3 with CD. What do we call it when we replace something? We've substituted. Substitution. Okay? Notice how we have the same thing right here, CD plus BC. It doesn't matter if it's written backwards. We know addition is addition. 2 plus 3 is equal to 3 plus 2. So we have the same thing here. Let's get rid of the thing that's the same. BD is equal to AC. Sorry, my pen is dying on me. BD is equal to AC. What do we call it when we get rid of the thing that's the same? That's the transitive property of equality. Okay? Now, we're backwards. We're trying to get to AC is congruent to BD. Well, we have it backwards. We got to flip it. What do we call it when we flip? Well, that's the symmetric property. We've gone from equal to congruence. That is the definition of congruence. This is the start of the hardest chapter that you're going to have. It is. The beginning, yeah, there's a lot of definitions, there's a lot of that stuff, but proofs are difficult. There is very few times where you're going to have to come up with all the statements and all the reasons. Most of them are something like this one, where you're given some statements, some reasons. Some statements, some reasons. But proofs are hard. You have to be willing to think. You have to be willing to justify what you are doing. And that is difficult. You have to take time. This isn't going to be quick. I went through these quick because I have to, but you can go back, you can re-listen, you can go through some of these things again. Okay? So, good job. If this took you 2 days, which it probably should because I'm approaching 50 minutes here, this takes time. This takes time. Good job today. Ask questions if you have them. Let me know what you need.